Half equations. Okay, so half equation, they could be oxidation, it could be reduction. Electrons could go on either side, so each time you have to have your wits about it, about yourself, and think about it. So here, think about the oxidation number. This is +1. This is 0. So to go from +1 to 0, it would have to have gained an electron. Okay, the electron always goes on the side with a more positive oxidation number. And it's a change of 1, so we just need 1 electron here. On this one, got -1, and we've got 0. It's not balanced though. We've got 2 chlorines here and only 1 here, so we need 2 there. So the chloride ions have lost electrons, gone from -1 to 0, but each chloride has gone from -1 to 0. So in total, 2 electrons have been lost. So again, the electrons have gone to the side with a more positive oxidation number. Be careful as well. First of all, you make sure the thing that is being oxidised or reduced is balanced. Okay, so we can get more difficult examples though. Look at this one here. We've got a dichromate going to the chromium ion. This is oxidation that you've seen before. Well, sorry, it's a reaction you've seen before, I should say. That where you've seen potassium dichromate, acidified potassium dichromate, oxidising various organic substances. So this is the actual half equation that's happening though. Then, so first thing to do is to balance the species. So if the chromium is going to change, this one here, we have 2 chromiums here. We started off only 1 over here, so we're going to need 2 lots of the chromium 3+. So we've got to balance those first off. So that's step number 1. Step number 2 then is to assign the oxidation numbers. So the oxygen is -2 times 7 is -14. So each chromium then must be +6, get to +12, because it's got to come to -2 altogether. Here they're just charged, aren't they? So it's 3+, so it's 3+, but there's 2 of them again. So then we're going to add electrons to the side of the more positive oxidation number, which we just seen is the left-hand side. So 6. Now if you look, this has only gone from +6 to 3, so I think it only needs 3 electrons. But there's 2 chromiums going from +6 to 3. So they each need 3 electrons, so 2 of them then need a total of 6 electrons to make that change. And again, the electrons go on the side of the more positive oxidation number. Next step is to balance the waters. So, balance the oxygens using water. So 7 oxygens here. There's no oxygens on this side, so I need 7 waters to balance that. And then I need to balance the H pluses. So balance the hydrogens using H plus. So now I put 7 waters. I've got 7 times 2, 14 hydrogens on this side, and none on this side. So I put 14 H plus. Hence acid conditions. So you've got a dichromate ion being reduced, hence oxidising something else in acid conditions. This is orange, this is green. Right. What though if it's not acid conditions, or what if it's alkaline conditions? Well, it's very similar. Let's look at another example. We've got Cl minus going to ClO minus. Again, balance the thing being oxidised or reduced, so it's going to be the chlorine. You can see it is balanced, so we don't need to do anything on this occasion. Assign oxidation numbers. It's got -1 here. The oxygen is going to be -2. So to get to -1, that chlorine must be +1. And again, we're going to add electrons to the side that's more positive. So the chlorine's gone from -1 to +1. So it has lost 2 electrons. We had 2 electrons on this side. And this is where we diverge a bit between our methods when it's in alkali conditions. I'm now going to balance the charge of each side of the reaction with hydroxide ions. So this side is -1 because there's 1 chloride. Here we've got 1 minus and then 2 minus, so a total of -3. So I'm going to need 2 hydroxide ions to balance that charge. To make it like so. And the last step then is to balance the oxygens of water again. So I have 2 oxygens on this side. I only had 1, so I need 1 more. And that's your final answer.